Okay, today we are going over CC1 3.1.1 Part 1, Review and Preview. Our first problem is problem 12. We need to complete each of the following Giant 1 problems. If you remember in class, any number inside of the Giant 1 has to have the same numerator and denominator. So I could do that different ways. In this case, I have to figure out what goes into the Giant 1. So 3 times the number is 18. Or I could think of it as 18 divided by 3 equals a number. Well, 18 divided by 3 is 6. So I know that the denominator is 6, so the numerator has to be 6 in that 1 because it has to be equal to 1. 3 times 6 is 18. 5 times 6 is 30. Moving to part B, 28 63rds equals something times 4 somethings. I'm going to keep using division to help me. So 28 divided by 4 equals 7. So I know my numerator has to be 7, which means my denominator is 7. 63 divided by 7 equals 9. Part C, 9/20 times the number equals something over 100. So 100 divided by 20 is 5. 9 times 5 is 45. Problem 13. Rachel says that when she ran 115 yards, she went farther than Beth, who only ran 327 feet. Is Rachel correct? Explain how you know. Remember that 1 yard equals 3 feet. So I can do this 2 different ways. The first way is I could say, well, I want to go from feet to yards. So if I want to go from feet to yards, I would take the 327 and divide it by 3. Or if I want to go from yards to feet, I can use multiplication and take 115 times 3. So I'm going to start with division, feet to yards. Okay, 3 goes into 3 one time. 3 times 1 is 3. Subtract, drop my 2. 3 times nothing goes into 2, so I have to put in a 0. Subtract, drop my 7. 3 times 9 is 27. So Beth ran 109 yards or 327 feet. Okay, going from yards to feet, I need to multiply. So 3 times 5 is 15. 3 times 1 is 3 plus 1 is 4. 3 times 1 is 3. So Rachel ran 345 feet or 115 yards. So is Rachel correct? Yes. Rachel is correct. She ran farther than Beth. And my math is my explanation. Okay, problem 14. Look at the 2 histograms below. They give you information about the heights of players on 2 basketball teams, the Tigers and the Panthers. We need to use the histograms to answer the following questions. Okay, part A, which team has taller players and which one has shorter players? Explain your thinking. So I'm going to look at the top half of my data and the bottom half of my data. And you'll notice with the tigers, I have a missing bar here. It's not really missing. There's just nobody in between 66 to 68 inches. So I'm going to separate my data into halves. We have the shorter half, and then we have the taller half. Okay, and what I'm going to do is I'm looking at taller right now. So I'm going to count. So between 72 and 75 inches for the tigers, I have 5 players. Between 75 and 78 inches, I have 3 players. And 78 to 81, I have 1 player. Then if I go over to the panthers, between 72 and 75, there are 2. Between 75 and 78, there are 3. And between 78 and 81 inches, there are 2. For those taller players, tigers have 5 plus 3 plus 1, which is 9. And for the panthers, 2 plus 3 plus 2 is 7. So the team with the taller players is the tigers. So the tigers have taller players. There are more players between 72 inches to 81 inches. Okay, so that means that the shorter players, okay, I'm going to look at the range from 63 inches to 72 inches. Okay, so 63 to 66, I have 1 player over on the panthers, and then 3 and 1 again between 69 and 72 inches. So there's 5 players on the shorter half of the graph. For the tigers, there's 1 in between 63 and 66. There are none between 66 and 69. But there are 2 between 69 and 72. 2 plus 1 is 3. So the panthers are shorter because there are more players between 63 inches to 72 inches. Part B, which team has heights that vary more? Explain your thinking. Okay, so I'm going to look at both of these and I'm going to look at how they're kind of spread out. And if I look at the panthers, they kind of go up and down and up and back down. They're pretty varied. Okay, meaning most of my data for the panthers is kind of spread out. For tigers, most of the players are between 72 to 75 inches, but it kind of just makes one curve. It's not as spread out. So, for part B, the heights that vary more are the panthers. Again, it's because the data is more spread out. in the different bins. Okay, part C, which team has more players that are about the same height? Well, that's the Tigers. Most players, it has one bin with the highest frequency. So, Tigers, there is one bin and that's the 72 inches to 75 inches with the highest frequency. Now that means it's the tallest, or has the bar with more players than the other bars. Okay, I wouldn't write what's in the parentheses. That's me just explaining it to you. Okay, I'm looking at this 5 here. If I look at the Panthers, there's 3 and 3. There's not really one bar that's taller than everybody else's. Okay, moving to problem 15, find the measure indicated in each question below. Find the perimeter of the triangle. Okay, if we remember, the perimeter is the outside edge, like we're building a fence around the outside. So we add them together. In this case, I have some decimals that I'm going to need to add. I can fill in with zeros. 5 plus 0 is 5. 2 plus 2 plus 0 is 4. Bring my decimal point down. 7 plus 7 is 14. Plus 8 is 24. So my perimeter is 24 and 45 hundredths, 40 centimeters. Okay, I need to make sure that I'm labeling. Part B, I'm finding area and perimeter. Okay, so my perimeter, again, I'm adding. So 8 plus 2 plus 8 plus 2. That's 10 plus 10, which is 20 inches. My area, I multiply my length times my width, which is 16 inches squared. Do not forget to square your answer. I could also write it as 16 square inches, or like that. Part C, find the area of the large rectangle. I have 4 across the top, and 1, 2, 3, 4, 5, 6, 7 down. So my area is all those squares. I can count them, but an easier way to do this is to know 4 times 7, which is 28. I do not have units, so it's just units squared. Okay, problem 16. Write down at least 3 different pairs of numbers that add together to get 1. Okay, I could write down a half plus a half in decimal form. I could do 1/4 plus 3/4. I could do, maybe it's 0.75, so 75 hundredths plus 25 hundredths. The key word is we're adding. As always,